The introduction of vaccines has benefited society by preventing and controlling the spread of diseases. However, due to slight risks, it has become a controversial topic in recent decades. Vaccination is a method of providing artificial acquired immunity by stimulating a primary response using a weakened or inactivated antigen. The time taken to fight this infection is relatively long. This is because appropriate T and B cells first need to be activated and cloned, and time is needed for cytotoxic T cells to kill infected cells and for plasma B cells to secrete antibodies to neutralize an antigen. During this response, memory T and B cells specific to the antigen are produced and remain in the body. Therefore, if the same antigen re-enters, a secondary response can be initiated, where memory B cells will reactivate the antibodies created following vaccination and secrete them in much larger amounts. This results in a faster, longer-lasting response when in contact with the real pathogen. Current public vaccination programs help control and prevent spread of disease through the concept of herd immunity. This occurs when a high percentage of the population is protected through vaccination. Therefore, the unvaccinated people have a very low risk of becoming infected because the transmission of the disease has been reduced to a level that is too low to maintain. This is important in protecting those who are too young to be vaccinated or cannot be vaccinated due to allergies and diseases that weaken the immune system, such as HIV. Maintaining the herd immunity threshold, which is the percentage of the population that has to be vaccinated, is very important. For example, in 2015, the fee of the mumps rubella vaccine causing autism decreased the 90 to 95% threshold, subsequently leading to the resurgence of 900 measles cases in the United States. Vaccination programs have been recognized as one of the most successful public health programs used to prevent the spread and occurrence of once common diseases. Smallpox was an airborne disease caused by the variola virus and is transmitted via saliva droplets or contaminated objects of an infected person. Early symptoms include high fever and fatigue. The virus then produces a rash, particularly on your face, arms, and legs. The resulting spots become filled with clear fluid and later pus. This forms a crust which eventually dries and falls off. When the immune system encounters the virus, this can initiate a cell-mediated response, which is controlled by T cells. The macrophage first engulfs the antigen through phagocytosis and presents these antigens on its surface using the MHC2 molecule. It then moves into the lymph nodes and activates the helper T cell through the T cell receptor that matches the antigen. The activated helper T cell releases cytokines such as interleukin-2 to stimulate the cloning and differentiation of cytotoxic and memory T cells. The cytotoxic T cells migrate to the site of infection, binding with infected cells, releasing the toxic chemical perforin to destroy them. Memory T cells remain in the body to respond to future infections by the same antigen. The sign of this immune response working can be seen as a fever. Against the variola virus, the immune response remains unsuccessful as the lymphocyte number notably decreases over the course of the infection. Therefore, smallpox was one of the most devastating diseases, accounting for 400,000 deaths in Europe at the end of the 18th century. The worldwide death toll continued to rise well into the 20th century, where mortality has been estimated at 300 to 500 million. The basis for vaccination began in 1796 when Edward Jenner, an English physician, observed that milkmaids who previously caught cowpox did not catch smallpox. Thus, he developed the first smallpox vaccine by inoculating a small boy with cowpox. Although it was not widely used at the time and therefore fairly ineffective, this was a medical breakthrough that paved way for later success. In 1967, the WHO committed itself to the intensified eradication program to eliminate smallpox globally. This involved a herd immunity threshold of at least 80% and was extremely effective as the WHO declared it eradicated in 1979. Polio is a highly contagious viral disease that can cause paralysis. Prior to the development of polio vaccines, there were 25,000 to 50,000 new cases of polio occurring each year in the early 1950s. In 1954, Jonas Salk, an American scientist, developed and began a nationwide testing of the first polio vaccine, which used an inactivated virus. However, 200 people contracted the disease and 11 died due to a contaminated batch manufactured by Carter Laboratories. Hence, this was ineffective but later carefully regulated. In 1961, Albert Sabine's oral vaccine, which used a live but weakened form of the virus, planted Salk's injected vaccine, as it not only protects those vaccinated, but others around them. Although the WHO declared that polio has been eradicated from the Western Hemisphere in 1994 due to mass immunization using Sabine's vaccine, there is a very slight risk of the live vaccine causing vaccine-induced polio. Hence, there has been debate about the use of vaccines protecting against diseases or causing more harm. The Global Polio Eradication Initiative, launched in 1988 by the WHO using the Sabine and Salk vaccines, involved mass immunization. This is highly effective as polio cases declined by over 99%. Resurgences of the disease, mainly in developing countries, indicate that sustained vaccination within a population is required to completely eradicate the disease. Diphtheria is a contagious bacterial infection that infects the throat and upper airways, transmitted via airborne respiratory droplets. During the pre-vaccine era, there were 23,199 cases in Australia. However, after the development of the first diphtheria toxoid vaccine in 1923, which was subsequently used on a large scale in industrialized countries in the 1940s to 50s, incidence quickly declined. The result was compounded by WHO's launch of the expanded program on immunization in 1974, which boosted widespread immunization. This saw worldwide cases declining from 10,000 per year during 2000 to 2004 to 5,288 in 2005 to 2009. While diphtheria vaccination programs have been fairly effective in reducing the overall spread and occurrence, it remains a significant problem as it has not been eradicated, in addition to ongoing outbreaks in countries with poor EPI coverage. Therefore, it is through historical developments and continued improvements that have allowed the decrease in prevalence of once common diseases.